I'm about to start the next project that I've got in here, and it's something I've been putting off for a couple of years. And what I need to do, what I need to start looking at is the drive shaft that goes between the engine and the absorber. Now, what this is just a regular solid drive shaft. It's got obviously U-joints here and here, and there's a slip yoke in here with splines. You know, even when the stuff is brand new, there's always a little bit of play here in the U-joints and in the slip yoke. Now, what happens is, especially, I hear it mostly when engines are idling. Usually if I bring even the engine speed up to like 1100, 1200 RPM, the noise that I'm about to talk about will go away. And the noise that I have is it's probably a combination of the backlash in the U-joints and this, but I honestly think it's mostly the slip joint that has the clearance in it that gives it the play that it has. And what kind of happens is you know, you can probably imagine, even though that the crankshaft's spinning over at a pretty smooth rate, at least apparently it is, but the torque pulses coming out of the crankshaft are not even, because you got multiple cylinders, and you know, the torque goes up and down and up and down, and that basically creates an opportunity for either a vibration in here or an opportunity for it to work back and forth. And what it'll do is it creates a really loud rattling noise inside of the slip yoke here, which is, I think, where most of it's coming from. The way the torque pulses through here, you get a vibration and a rattling, and basically what it does is it rattles the bolts that hold this yoke to the back of the engine. It rattles them loose. And you would think I'd have a bigger problem with that type of a thing with a big V8. But the thing about the V8 is that for every revolution, there's more power strokes than there would be on a 4-cylinder. And because the frequency of the power strokes and the torque cycling coming through the drive shaft, it's a lower frequency, and that causes a problem. I think that causes a big problem sometimes with the damages that can happen to the drive shaft. And I wish I had taken the time to video how much play this actually has in it while the last engine was on here, because I could turn it back and forth. I could turn this part of it maybe that much, but because there's nothing holding it there, I can't hold on to it firmly enough to demonstrate it. But to show you, it was basically moving. I could probably move this back part here maybe that much. So between the slack in the U-joints, the slack in the spline, and the slack in this front U-joint, they need some attention. I need a way to remedy this. And so when it comes to the slack in here, the way I've been kind of working around it for the last 2 years basically is, before I run any test, I pump a couple pumps worth of grease into the U-joints, and there's a Zerk fitting there. By adding grease there, I'd put grease in between the splines of the slip yoke, and kind of give it the grease would act as a little bit of a cushion, and it would also solid things up. Having said all that, what I want to do now is I want to put a flexible coupling, or a flexible, they'll call it a flexible coupling here, between the drive shaft and the absorber. What I picked out was this, and what it is it's a flexible drive shaft coupler. What it's supposed to fit onto is like the first generation Dodge Chargers, I think, and Challengers, and I actually chose the one for a 6-cylinder engine. What I needed to do before I chose it was kind of figure out how much torque this thing was kind of intended to experience. And I think those 3.5s or 3.6 liters that they have in those cars, let's just say they make 250 foot-pounds of torque. And then let's just say between the torque converter, first gear, and everything like that, let's just say it's 4 to 1. So you take 250 foot-pounds, multiply it by 4, and you get 1,000. So my opinion is this thing should be able to handle 1,000 foot-pounds pretty reasonably. So what it does, these 3 bolt holes go together, and these 3 bolt holes go together. So bolts will go through like that on one side and like that on the other, and it'll kind of go in between there. So, and the idea is that between these 2 things here, it's got this cushion in between these holes, these fastening holes here. So basically, what's in between there will kind of act as a cushion or a damper or a spring. So, and because rubber to me kind of has a tendency to have damping qualities, so I guess you could call this sort of like a spring damper, a spring/damper. I think it should do that. So basically what it'll do in here is it'll take those pulse peaks, those any kind of like a sharp spike in force coming through there, or a sharp spike in torque coming through there, and it'll give it a little bit of a cushion. And while I'm thinking about it, another thing about this is that it's roughly designed to spin at the same speeds as the engine spins, roughly. So what I need to do is get that mounted in between there. And what you can kind of imagine is like, with this in place, it would be like the difference between hitting something with a metal hammer and hitting something with a rubber mallet. That's the idea, is to reduce those spikes in force so that the U-joints last longer and the slip joint lasts longer. So as per usual, what I'm going to do before I try to make any kind of a mount for this out of metal, which takes a long time and can be expensive depending on the material, what I'm going to do is, like usual, we're going to go inside. I'm going to start, I'm going to take my dial calipers in there, or my calipers in there, start taking some dimensions on this, start designing what I want in Fusion 360, and then once I have something that I think is probably about what I want, then we can take that model and send it to the printer, and then we can physically fit this stuff in here before I even make anything out of metal. That's the way I like to do it. Alright, so let me get started with that. Okay, so I guess this is the first of the 2 parts that I need to make, and yeah, this is a problem I frequently run into with when I'm mixing a 6-bolt pattern with a 4-bolt pattern, and I was hoping that that this larger diameter bolt pattern here was going to be enough to clear these inner ones, but looks like we got some interference there. So I'm probably going to have to do something, do some clearancing there with the fasteners once they're installed there. I think that's probably the way I'm going to handle that. But first what we got to do is I want to print this off and see if I'm even close. But the idea is that that flexible coupling that goes on here will kind of, these holes here will be threaded, and that flexible coupling will bolt to this piece via these holes, and then these holes here are just, well, so the heads of the bolts aren't interfering with this surface here. So that's the purpose of those, and hopefully there's enough clearance in there for things to move around, because basically if the parts don't have enough clearance, then I'll be right back where I started from, because there won't be enough room for the flexible coupling to flex. This is my first try with this, so let me get this over the printer and we can get going on that. Okay, so I got the parts printed off. Here's that coupler again, and let's have a look at how we did here. Get kind of a basic idea of what I have in mind. Except this kind of goes on here like this. like that. And then this piece kind of goes on here like something like this, like that. So kind of the idea is that, you know, like the green piece is going to be driven, and it's going to drive that torque through this flexible coupling and then into this driven part of it. So, and the idea is that it's flexible, and it gives it some flex in there, so it's not so that the vibrations are kind of damped out a little bit, or the peaks of the forces are knocked down a little bit. So it looks like it turned out all right. You know, and then the nice thing about the 3D printer is that we can have a look and see, because I can already see that there's changes I want to make that I found out by, you know, printing this off. But we can deal with that, and then what we can do is just take this out into the garage and kind of mock it up there on the dyno and see if there's any other adjustments I should make. So let's go do that next. Alright, so now I'm just going to mock this up here and basically just run these fasteners in and just make sure that the bolt pattern that I have in there is going to be correct. Alright, so they seem to fit in there pretty good. So let's have a look here how we're going to do this. That on there. That. I don't think this one, the way I've got that done there, I don't think it matters. At least not right now, it doesn't matter. We'll go on there like this. That. So, yeah, I don't have the fasteners for, you know, bolting these together right now, but that's something I have to get ordered. And just give me a second and let me put the drive shaft on there real quick. Okay, so this is basically what I have in mind here. And it looks like most of my dimensions that I came up with seem okay. These bolt patterns here, I actually took off of the drawings that I used to make this, so they should be the same anyway. But they do seem to fit all right between here and here and here and here. And it looks like the bolt pattern that I put in here, it looks like I got that pretty close to this, so that should be okay. Now, obviously, those 3D printed parts are going to get shredded, so I need to make this out of steel. Let's see, the other thing is, the way this is, because it sticks out so far, what I am a little bit worried about is that there could be if I don't get everything aligned right, there could be wobbling going on, or there could be like things could start whipping around in there, and I don't like the idea of that, so I'm a little bit concerned about that. So, but anyway, this is basically what we've got to start with, and what I'll do coming up is I'll get the material ordered, we'll get started with machine work on here, and I'll also, when I order the material, I'll get some fasteners ordered for this too, so that we can bolt that together when the time comes. All right, but that's about all I got for this week, and we'll see you next time.